Gentlemen, today I will talk about purification of biomass. Purification is a special kind of pyrolysis, which is decomposition thermal without any external agent like oxygen or oxidation agents, but in low temperature between 200 and 300. This is requiring not so big energy requirements, and the deliver of my talk will be based on an article published in 2022 in Biofuel Research Journal called Oxidative Torrefaction and Torrefaction-Based Biorefining of Biomass, a critical review. The work was published by Professor Wei-Sin Chen from Taipei University of Technology in Taichung. The work is saying what is first, what pretreatment are needed, how different torrefaction and inert and oxidative, so addition, and of different biomass like bioalgae, woody biomass, and agricultural waste. Today talk about chemistry, mechanism, and kinetics occurring during thermochemical conversion, and how to design a reactor proper for this case. And then we go into 3 options of torrefaction. Professor Wei-Sin Chen qualified classification also as kind of pyrolysis because he generally are 2 concepts of pyrolysis: only thermal decomposition or energy microwave with using no agents, and with adding of oxygen or oxidative agent, like here is concept. Therefore, the professor classified oxidative classification from 200 to 300 also as pyrolysis, thus oxidative torrefaction. And last but not least, the preparation of products, char, gas, oil, to obtain chemicals, obtain power, and semiconductive polymer and fuels. There is using how to use different products. The parameters most of torrefaction included yield, solid yield, energy yield, which is how much fuel is used and its conversion is obtained, and energy, how much energy is from 1 kilogram, carbon enhancement, higher heating value enhancement, and energy mass and carbonatics index. The waste are biomass different waste born from agriculture, which are generally microalgae, which have important case of using for chemicals, hydrogen, and therefore after using can be also torrefied, may closing the loop of which this applied plant also fights with greenhouse effect because it's excellent of capture of carbon dioxide. So that is produced by torrefaction. This is the one of side effects, but torrefaction can close the loop, making that some of the waste would be catched. Pollution. Firstly, on interaction, how different biophenaries are made. The biophenaries are two groups, biochemical and thermochemical. Biochemical is using microbial and from biogas and from is classified from microbial or plant like microalgae or dark fermentation. Other method of production of fuels is using only thermochemical, so by oxidizing and such as bioice, syngas, and biochar. So transformed by heat to thermoreactor. Also that in this case, if is obtained by alcohols in such way by purification, it's then thermochemical product, not biomass fuel. The quality is in formation is due to feedstock, which is quantity with direct competition with human and animal food. So generally should be inedible for both cases. And second case, generation is mainly waste and energy crops due to complex. So, for example, willow especially grow for the combustion of energy. Third is photosynthetic microalgae and algae have kinds which are very supported by Professor Wei Chen, because she feels that it makes many appliances doing fuel fully or cycle can be used for chemicals and energy and even polymers by different technologies from dark fermentation, pyrolysis, and mushrooms. This is causing that is compared to petroleum has generally biomass obtained by fuel has less carbon and oxygen and alkali metal contents, which causes that is less efficient or and more pollutable right now. Thus, we need to add in this case some nanoparticles or even supplementary to upgrade to make during combustion this fuel similar to traditional. Purification is current topic quite important because as for biochar, which is excellent as fertilizer, so it's just pyrolyzing to get only mostly some ashes and solid part, which is called biochar, is very useful in case of fertilizer. Therefore, for biomass especially, all requires some analysis. Here we have how it's used and mostly work of torrefaction and it takes torrefaction and chemistry mechanism and parameters. Very few work is about analysis of both inert and oxidative torrefaction, which is an advantage, and circular economy aspects, and very few is to economic aspects and circular economy aspects. So this is the cases which the work is discussing. In the case of temperature, we have the classification is parted into 5 parts: initial heating up to 100, then pre-drying, post-drying, and after this is white clarification, which in time is short time in compare of drying it, and then solid cooling. The temperature of this clarification is between 200 and 300, so this is shorter and time than high heating and requiring quite efficient because quite rate and no if we want much solid as solid part. Here we have several treatment used as for biomass, chemical, mechanical, thermal, and hydrothermal, and biological. Hydrothermal is here divided as other part than thermal, because, however, thermal has no agent for supporting this treatment, while hydrothermal is using liquid, special like water, or carbon dioxide to enhance the breaking of the molecules for easier to torrefy. The advantage is suited well for liquidated biomass, hydrothermal, low corrosion and catalyst requirements. But disadvantage of such hydrothermal is complex due to high pressure and high process cost. Hydrothermal also requires is low corrosion here because the material is special steel, which is less corroded. But this special steel is much more costly. And commercial is limited commercial. Biological treatment by bacteria, fungi, insect is low cost, low energy, no chemical emissions, but it's very slow. Thus, in fact, in this case, there are works like Professor Ragauskas to make genetically modified to be more faster and better way to be more attractive commercially. Mechanical treatment is fine because improve physical properties, increases surface area low cost, but for making well, high energy, and is commonly applied, but the disadvantage energy, how to reduce such energy. Chemical treatment is using steam explosion, ammonia fiber, acid alkaline, pH control liquid, hot and ionic liquids, and eutectics. There's improved biomass for processing, for production of quality enhancement, but generates more cost because some, especially acids, are corrosive, and use of chemical. And another is side effects of design. It's very employable in commercial scale. Another part is classification as inert and oxidative. The inert is using no oxygen and only thermal happens. Both at oxidation, which also oxidation is such that is maybe more efficient but produce some hazardous gases. which needs to be separated for and higher safety rules than in case of only non-oxidative purification. The yield that carbon dioxide medium has grindability of the biomass caused by formation of pores. It is only also oxidative, and this T is split, and to non-oxidative is microwave purification, which leaves less energy. But still very few studies are obtained, therefore it's not very widely explained, because he uses only review, not by himself, but showing that this classification should be more studies about this. The rate kinetic parameters is a series of complex reactions that but less than microbial, more 500, and this is two steps, one step and multi-step. The one-step classification can predict xylane, cellulose, and lignin deforestation, and can predict over long residence time. But in case if we want to short-term product, it's got some troubles that requires to modify. There are much works about this, but still not published mostly. So we'll come wait for results or made by us by some others. The oxidative polymeric purification effects on the effects of properties of torrefied waste. In case of woody biomass, is especially fine because oxidative give much better conversion, which is hard to obtain only by one agent, only by acid or only by heat, especially of trees from coniferous tree. So, especially hard and oxidative is some shorter resident time, but overall is great as a standard. The other material are mostly different ways, and in case of the corn cob or coconut fiber oil plant, the requirements mostly are for oil plant are much due to size. Other plants that fiber can be more length, while oil palm fiber requires especially low particles size to be efficiently reproduced. But they give high energy yield, higher than anaphors. Only some as oil from food branch as so of 95% can be energy yield, which is much higher than other. Or rice straw is only 83 up to. So olive, this is especially good for branch fruits, empty fruit branch, which is unlikely to be so hardly to fermented. However, work of pineapple by Professor give had also dark fermentation. So this is using cooperation of these two techniques can be useful for fully utilize the waste. The other cases, twisting, is that also very fine but very short is paralysis of spruce cellulose. Only other case that by paralysis of starification to obtain high 95%, so almost like grams, is very high. Other case to utilize sodas is only by using mushrooms, so white root of brown root, but white root or brown root, that is very slowly. So this is the fast way to utilize and give some energy over much. The torrefication of algae is very slow compared to much. Only willow is similar to fine tree, but willow on other methods is not very well researched. So this is the question what to do in case of microbial, why microalgae is very often checked, but still very low in compared to other methods. So the algae requires more conversion by microbial due to low efficiency in compared to other waste. So this is the trouble, but still the torrefaction is much faster than gas fermentation on biological level, which is if we want to remove much waste, and we have to, the torrefaction hypolysis is much better and much suitable. So we need to develop two methods to have fast utilization and relatively slow. So this is the difficulties, and effects of energy yield are fine on this case. So thank you very much for listening to me. That's some points at other. Thank you very much for listening to me.